So, yeah, hi, I'm Alex again. I originally was gonna give this talk at BazelCon, but then I got an awesome opportunity to offer it here instead. Okay. I'm not to write rules. I think that was the title I was given for this. Actually, the funny thing is that was just my sort of shorthand for it, but I never actually came back with a proper title. So here it is. Fine, go big. If I do this, is it good? That's fine. Okay, I really value having 30 minutes of time with this group of experts, so I'm going to try to make the best use of it and maybe leave lots of time for questions, because it seems like the last session had lots of good questions too. I do have a link to slides. There's some links throughout, so if it's useful, hopefully that's memorable enough, or if you wanted to take a picture or find me later. So about me, I worked at Google for a while. Tiago was on my team when I was there. We worked on lots of Bazel stuff. I've also worked on TAP, which is Google's continuous integration system, and the build results UI called Sponge, which most of you now know as Build Buddy. And we're also building something like that. But yes, there was all of these things have been done before. And I worked on like rolling out TypeScript and Angular to Google 3, and basically spent the whole time at Google like crazy about Bazel and continue to be. So this talk comes out of a lesson I learned from working with some of our customers. Should I take questions now? Yeah.
No, I was just waving as the customer.
I see. Yes. So yeah, my company Aspect, I'll give a talk at BazelCon about what we do, so I'm not going to waste time on it. But basically, I've been doing consulting with a lot of companies, and they ask like, "What's wrong with my rules? Like, I'm trying to write a rule to run less, or some CSS preprocessor, let's say, or every ecosystem has a bunch of tools, and you think like, okay, it looks like I'm supposed to write rules. And if you look at what Google does, that is what Google does. And so if you follow the sort of the prescribed dogma around Bazel, you'll often accidentally go down that path. And this whole talk is basically that you shouldn't do that. They're complex and they're unnecessary. It's extra awkward that I'm giving this talk to the advanced room about why beginners shouldn't write rules, and then later the beginners upstairs are going to have a talk about how to write rules. I don't know. It's so if you meet some of them later, you can argue about who was right. Okay, so you all know this very quickly. So actions are build steps that happen in Bazel. Each one of them is a subprocess that Bazel spawns. Bazel doesn't really know how to do anything except accidentally it has C++ and Java and Python and stuff built in, but they're fixing that. And you think of an action very roughly as like, there's some inputs and I run a command and the command transforms those inputs into outputs, like problem solved. And so if this is the graph that you have in your head, this is a very simple model of actions, but it's often expressive enough for the task at hand. And so if this is what you need, you do not need to write a rule. And I'm basically going to explain why. So the opposite thing, so if it's not that simple graph, what is it? So rules are technically, so there's two graphs in Bazel, and I remember like when I first started at Google, I got to go meet Carl Quinn and Christian Kemper in their room, and Carl was like, okay, so yeah, so we have, basically you have a dependency graph and it's lowered into an action graph, and he said like some computer science terms, and I was immediately intimidated. And it does that by like a bunch of APIs that rules can do that are not in that simple graph. So one of them is, when I say the outputs, that's really what's called the default outputs. It comes out of default info, which is a provider of the default outputs, but the default outputs are often enough. If they're not, then there's other named outputs, which are output groups. There's also outputs that aren't named. You can run multiple actions inside of a rule. So that graph I showed us, sometimes there's inputs and then there's a bunch of little bubbles of subtools to run. And sometimes those tools don't have to run because they're not required for the outputs you asked for. So really, like a rule can produce a whole graph of actions. That graph can also, so providers like default info, but you can make up your own. And then there's some built into Bazel. And then you can actually walk the graph, and now things get really complicated. You run aspects, just coincidentally named the same as my company. You can also have aspects on your aspects, which I think the JS team at Google needed to do for closure or something, which I never understood, and I hope I never will. Which can be necessary, right? I'm not saying that you should never do these things, but don't do them by accident. Okay, so that stuff is all hard. So Jay's going to teach about it from 3 to 5. And my argument is like, there's really two different constituencies. Like the experts in this room, like how many of you have already written rules? Like almost, okay, that's like 80%. You're probably the people who do write rules. So you maybe, I don't know if you're going to go to Jay's session. and you all are experts at Bazel. Like this is part of your career path at this point. Like you're here, you're not just product engineers who are trying to touch it as little as possible. But that's what all the end users of Bazel are. Those people. So what do those people do? If they're just a product engineer, they can either go to Jay's talk and become Jay or become one of you, or they can ask you or Jay, hey, can you write this rule for me? I need to use this random tool for my job because my old build did, and you made me move to Bazel. And the third option is use a macro. So this talk is basically, okay, if you're not going to write rules, what are you going to do? You're going to write macros. Sorry, not you, because you all know how to write rules. If you don't know how to write rules and you don't want to learn how to write rules, you should write macros. You probably all know that macros look the same as rules. And this is actually a design feature of Bazel because a lot of times you need to switch from one to the other and you don't want to have to update all the use sites. So there is no way from the use site that I know of, maybe somebody will correct me, to tell whether you're using a rule or a macro. And if there was a way to tell, Hiram's law, which of course is at a large scale, any little tiny implementation detail is depended on by somebody. Hiram's law would say, if it's possible to distinguish between the two, then there's 100,000 locations in Google 3 that do distinguish between the two, and you can no longer just wrap a rule with a macro and get away with it. That would break things.
I believe if you pass it to the type function, you can find out.
You can find out it's a function or a rule does not look like a function. Okay.
Yeah, because
no, but not from a build file. This is from a build file, right? Because users are writing build files, or Gazelle is generating
a macro, which is close enough.
Okay, so like TS project as an example, like whatever, it so happens to be a macro. It actually has to be a macro because Bazel says they're going to deprecate named outputs at some point, and so in favor of ctx.adder.outputs. Anyway, separate discussion. But the point here is you can switch back and forth, right? So if you do write a macro because you listened to me, and then it turns out that Jay was right, you can always switch from one to the other later. And a lot of times you need a macro to wrap a rule to set defaults, and so you may end up having to have both. But for end users, they just write a macro, right? And a macro is some function. I'm sure everybody has seen one of these because this is the expert room. So I guess I should go back. So what is this some rule thing, right? So the macro has to call, like, it can't be 100% macro, right? It has to like invoke an action, and macros can't invoke actions. So to go back to that original picture where an action is this really simple thing, you need some rule that's going to transform the inputs to the outputs. And gen rule is the key to how to do this, right? So this guy, I totally agreed with this blog post. I will read this out loud. The Bazel user guide and the user manual preach the benefits of giving Bazel full control over your build process by rewriting all build processes using Bazel native rule sets, as Google reportedly does internally. Cannot confirm or deny. It's an immense amount of work. So yes, Google does an immense amount of work to make everything work with Bazel. But of course, like a bunch of the tools grew up around it. So like it wasn't even that somebody had to change it later. Like it's been in place since 2008 or 2009 or so that every tool has been written with Bazel in mind. The entire Go programming language is written in Bazel in mind. So why is gen rule the key? So like I said, you can make a single action run under a macro. It sucks because it gives you an arbitrary bash one-liner. And when I use the word one here, that's not actually the number one. It's actually, you just use triple quotes and then you make 100 lines. It's usually not hermetic because you call out to whatever. I'm sure Andreas can talk about the horrible things that like rules SH and Nix can do to try to like fix this problem. But like you don't have to declare your dependencies really. You can, but who would? It's you write it in bash, which is it bash 3 or bash 4? Are you on Windows? If you have Windows users, then which I often do, then you have to think about that. And then like the semantics are just crazy. Gen rule just does everything different. Like expand location gives you different results than if you write it into it. Like if you use ctx.expand locations. And stamping, like gen rule has a stamp equals number. Doesn't have anything to do with how you would stamp in your own rules. Okay, so gen rule is not the key. Comedy routine. Okay, so we cross that out. So run binary is the key. Run binary fixes those things about gen rule, but and it looks like this, right? You load it from Bazel Skylib. If you haven't like read every page on the documentation for Bazel Skylib, you should. There's lots of gems in there. But it can't write directory outputs because directory outputs were added to Bazel slightly after Google mostly adopted it. You can't change the progress message, so people can't see, the terrible hack like the dog has. And you can't use mnemonics, which means you can't use all of the systems that are based around mnemonics, like modify execution info, which is an amazing way to say, for this mnemonic, actually don't try to run that remotely. Okay, so comedy routine continues. So the other run binary fixes themselves. So Aspect Bazel lib is basically stuff that could go into Skylib, but it's too hard to ask somebody to merge all of our stuff, and maybe they don't agree with all of it. So we have more libraries. It's not a fork of Skylib. It's like an addition. So we have a run binary, which whatever. Here's the attributes that fixes the things I just mentioned. So also, I definitely recommend checking out our Bazel lib, because just like Bazel Skylib, if you know all the things in there, it will save you lots of time sometimes. Okay, so now there's another problem, right? Which is, okay, so we can use run binary, and now we know that any tool, we can just run it as an action, but then most tools are gonna not work. Okay, so now you're like, okay, so see, I have to write custom rules because I have to write custom tools. Don't do that either. Like, yeah, we did that at Google. It's both a lot of extra work, but also makes your migration riskier, because now the people who are running the Bazel build are getting different results from the people who run the non-Bazel build, because you ran a totally different compiler, or even a subtly different compiler. So most tools, you can make them work under Bazel. I like to ask when people say like, oh, well, this tool doesn't work with Bazel. Why not? How can it tell that it's running under Bazel? Oh, well, you know, the working directory is wrong. Okay, well, you can just run it in the right working directory then, and does that solve your problem? And a lot of times, like, there's just like a stop, press the brakes, don't rewrite the tool yet. Think about whether you can make it work, and you almost always can. Think about it in terms of the POSIX process API. You have standard in, you have standard out, you have a working directory, you have signals. Like, yeah, like you have a few things, but like we all know them. They're in every programming language. They can usually be used to fix it. There's 3 ways. The first is monkey patching. I know everybody loves monkey patching. I'm not going to ask you to raise your hands. So in Node, there's a flag that actually lets you run some arbitrary script before the entry point. So even if the entry point is some third-party tool that you fetched and it's hermetic and everything, you can still like change the working directory inside of a -- require with like a little one-liner. Same thing in JVM. Like, you know, I guess I don't know if there's like security in the JVM now that tries to stop you, but I've always injected stuff on the class path. Works fine. Make sure it's at the beginning. You can overwrite any class you feel like. Okay, so like, you know, mostly joking, but sometimes this is the thing to do.
You may have to do it on the class path, but you can still do it.
Right. Yes, exactly. Like, dig into your runtime enough, become an expert at the runtime, and like, hey, is it possible? This talk is mostly about what's possible. In-process wrapper, so this is less monkey patching. This is, instead of calling the tool's entry point, write your own entry point, and then find whatever library code the tool runs, and then like, you know, just peel one layer off, and then you call it. That gives you lots of power to like adapt the CLI of the tool so that like Bazel will be happy. So, you know, for example, you could like steal standard out and write standard out to a file inside of your in-process wrapper, so that now, because the tool insists on writing a standard out and Bazel insists that it will only use standard out for logging, you can make that work. And then the last example, which is the most common, which we've all done many, many times, you write a bash script and you just like call that, and then it wraps the thing. So now you have 2 processes, like the bash script calls the child process, or you can be fancy and replace the current process so that while your slow thing is running, users don't see, like, you know, you're not using more RAM on their machine with an extra wrapper or something. Okay, so the last, so I mentioned standard out and standard error. Exit code, sometimes you need to capture just because the tool thinks that like, oh, well, my exit code will be the number of things that I did. And you're like, no, you have to exit 0, Bazel sets. chdir, throwing away log spam. Lots of tools write stuff to standard out. Bazel, for some reason, doesn't have any built-in way to say throw away standard out from tools when they succeed. You can use a wrapper. So that third technique, you write a parent process, you can like do basically anything. And I would love for us to have a run binary that has a wrapper built in. Like, so far, the ones that I showed earlier, none of them tries to have a wrapper, because wrappers bring their own set of issues like bash dependency. But if you do have a wrapper, then you can usually fix any stuff that the tool does. Okay, so I've got some examples, but I also want to leave some time for questions. So I think I'm going to pause before I go into examples. And maybe I'll even just use the examples to illustrate answers to the questions. So does anybody have any questions at this time? Yeah.
Basically, you're saying that it's better to use your own language and write a CI tool that then integrates with Bazel than run the whole thing, rewrite the whole thing in Starlet as a Bazel tool, right?
Right. So I mean, you're always going to have some amount of Starlark and then some amount of whatever language runtime the thing needs, that the user needs to run the tool.
I'm in this point where I would prefer, of course, to write most of my infrastructure, my known language instead of Starlark. But the problem I see there is you lose the nice things of Bazel, like inputs out the control. If you are doing the correct things, you are not using stuff outside of the Bazel graph of the inputs, outputs, stuff like that, right?
Do you mean hermeticity?
Yeah, exactly.
Hermeticity you still get. Because whatever the action runs under, whatever spawn strategy, whatever guarantees that thing gives you, that you declared all the inputs, you'll still get if you use run binary as the tool. So if you have a macro calls run binary tries to read a file, you didn't declare that file as an input to run binary using the data attribute or whatever, and your sandboxing is strong enough that it should fail.
Okay, yeah, so sandboxing prevents the binary from doing weird stuff outside the hermetic environment.
Right. And writing your own rule gives you zero control over that anyway. In fact, writing your own rule, one of the first mistakes you'll make is forget to declare some input, especially you create like a manifest that is an extra input to the thing, and you'll accidentally succeed because of non-hermeticity, or like you're in Node, it will accidentally walk up the file system and find a package JSON file and accidentally succeed. So I'd say writing your own rule is more likely to give you hermeticity issues than using run binary. Yeah.
Do you have additional utilities for working with source? Because a lot of the tools kind of assume you're running in the source tree, and so you kind of need to like reproject part of the source that comes from dependencies, that kind of stuff.
Yeah, so this goes back to working directory. So if the tool, so the question is like, what happens if the tool wants to run on the sources? Like what if it wants to write to the source tree, I guess would be one example. So lots of tools in the JavaScript ecosystem write to the current working directory. And in fact, like React scripts, for example, is like a build system that everybody in React uses, and you have to write to /dist. No choices, or maybe it's /build. Yeah, so the answer is that, okay, the current working directory that Bazel runs the action in has to be the output tree so that it happens to land in the place that Bazel expects, right? You declare some outputs, you get an error from Bazel saying nothing wrote, like the following output was declared, but nothing was written there because the action didn't actually write to that location. Great thing for somebody's wrapper to do, like big problem in general in Bazel is, can you tell me where the tool did run it, right? Stuff, like can you run it under some sort of strace file, like operating system level, tell me where it wrote. And then you just need to make those things line up. So you just chdir to the output tree. It might seem weird to run a Bazel action in an output tree. Actually, our rules.js only runs actions in the output tree because that's the only place that all of the, it's the only place that the node tool finds everything it needs. Yeah, so I don't think the distinction between rules and macros gets you into any trouble with regard to that particular problem either. Yeah.
One place I've played with macros and rules and found the tension is where you want to like replace default behaviors. So if you're like, I have Java code, I want to lint it all. And so I write a macro that like adds a linting test or something, where the macro way kind of sucks because let's say you're using rules Docker, it's not going to use your macro. It's going to use the default Java library or whatever rather than your macro. But like the aspect world is fiddly and complicated, right? People need flags, people need to configure it. Maybe you want to disable it for generating code or something that is fiddly. Do you have any thoughts or experience in like bridging that gap?
Yeah, so what happens if you, like, how do you set defaults on native rules, basically? You should disallow users from loading native rules, is a simple answer. And we have a Buildifier check at one client where Andrew works. Actually, I don't think we were able to write it into Buildifier. I think maybe one thing I would love to get away from this conference is like, there's a ton of stuff that could go in Buildifier as lints, and I just haven't seen any contributions land there in a while.
Buildifier is kind of horrible.
So you can write something out of Buildifier, but basically tell users don't load directly from IO Bazel rules Docker or IO Bazel rules Go or wherever. Instead, load from my like macro that wraps it. So we have a pattern of like having like a default.bizzle, although I think maybe it'd just be better to call it def.bizzle. It has the usual caveat that you can easily have way too many eager load statements in that file. So if you say, hey, we're going to have one default.bizzle at the top of the tree, everybody should load from there. And then it will have load statements on every language because it starts to grow. Now everybody has to run Bazel analysis over all of the third-party graph, even though they were only trying to like,
and this will trigger fetching of every
right. So don't eager fetch, like you need, water, that's fine. You should have one def bizzle per load statement essentially, or you have to reason about not grouping them up that way. Let me also, while I'm doing caveats, let me point out one other thing about macros. They are very leaky abstraction, very easily abused in a large code base. Your users writing macros will make lots of terrible mistakes. There's a macro style guide on the Bazel website that you should follow. I feel like we had more things like that could go on there too. I know Tiago and I have discussed this before. But like, it should always take a name attribute. I got clever for a while until that made me stop of like, oh, well, I don't need a name attribute because the name will default to whatever. And then like now Buildifier doesn't work anymore, or Bulldozer, sorry, it doesn't work anymore. And there's a bunch of other things like your macro should produce one rule whose name matches the name that the user provided. And that should be the thing that the user sort of expected to be the end product of the rule and so on. The end product of the macro, sorry.
And it needs to deal with visibility.
And you have to propagate visibility and tags and so on into the right rules that you call, but maybe not all of them. And sometimes there is no right answer, like do I have to pass tags to all of them? Yes, there are these caveats to exist. Yeah.
Have you noticed any differences in like how tools like Bazel.Dev and stuff like that work and behave with generals and rules? Like just last week we had a general and Bazel.Dev was not catching some changes, and then we switched it to a simple rule, and that made Bazel.Dev basically catch the differences. So I'm wondering if in the Bazel way, the Bazel query, how does it differentiate between these two concepts? Yeah.
So yeah, macros are evaluated at the loading phase, which is to say if the user queries, they will see the products of the macro. Very leaky abstraction. Users are pretty confused by Bazel query anyway, so I don't know that that's like for an end user who's sort of, the product engineer who I'm sort of alluding to here, somebody who's a user at your company. I don't think that that's a problem for them. So tools like Bazel.Diff or Target Determinator, which is under Bazel Contrib, are trying to predict which targets are affected by file changes. Targets, of course, can map to multiple actions. The fact that your thing is a macro just means that your target expands into some other set of actions. I don't think that that has any bearing on whether Bazel.Diff or Target Determinator would get the right answer. Does that sound right, Daniel? Yeah.
Yeah, it's something kind of related to that, although this might be a very Google-specific problem to have. So as you said, one of the key differences between the macro and the rule is that a rule can build up an arbitrary graph of actions. And one of the things you can do with that is you can have action outputs that don't have a label associated with them. And when you don't associate things with a label, that makes it much harder for people to accidentally depend on them, which then makes it hard for you to change an implementation detail in the future.
Mm-hmm.
I'm wondering, is this actually a Google-shaped problem, or is this something that people are, in your experience, are generally worried about, that people might accidentally come to depend on internal nodes of the build graph that are not supposed to be consumed by anyone else, by other rules?
Yeah, so as a rule maintainer or as a build system maintainer, do you end up on the, promising too much of a public API? And for sure, that's a problem. Macros and rules both have this problem. Like for the example you gave, under either you can choose to pre-declare an output or not. And in some cases, you pre-declare an output, like a .js file, for example. Should it be a pre-declared output? Well, it makes it a lot easier to reference later in the graph as the entry point for some program. But it does mean that now users are tied to the fact that that's what you produce. And if you're like, oh, we're only going to produce .cjs files now, then yeah, that like users observe that change. So I think, again, it's important to keep in mind, but I don't think that using macros gives you more of this problem.
I mean, it does. So my understanding of the run binary approach is that surely you're basically forced to associate a label with every single output.
No.
Or does run binary actually let you control whether there will be a label? And if it does let you control whether there will be a label,
you can produce a directory.
That elsewhere.
You can produce a directory. But you're right that if you produce files that nobody declared should be outputs, then Bazel won't copy them back out of the sandbox into the Bazel out tree at all. So yes, you do have to declare what the outputs are going to be. And I think directories is your only way to avoid labeling that, right? Yeah.
The label to output mapping is a default info anyway, so.
Let me show some examples just because they might motivate other questions. I know there's only a couple minutes left, so mostly I'll just point to these as links that you can look at later. So in writing rules, I needed to assert what their outputs were. This is just a macro rather than writing a whole rule. If I click this, is okay, yeah, okay. Size and timeout, like you have to give some things, and then we basically use write file to make a shell script. Then we use a native sh test to run the shell script, and then the macro uses a thing called params file that just takes the root paths of whatever it sees in its run files and writes them into a manifest, and then we put that into a text file, and then we diff it against what the user said should be the actual. So like using the building blocks basically from Skylib or Aspect Bazel.Lib, like there's a fair amount of expressivity in what you can construct. This one, so here, this is the definition of our Mocha test rule. There's a lot of test runners in JavaScript. If you want to write a rule for every one of them, you're going to have lots of rules underscore blah, 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 and you're not going to be able to maintain them all. All you really needed to do in this case was rules.js and rules Python both have a way to sort of generate an entry point for a third-party package. So Mocha came from NPM, and there's a place you can load from to just get the run binary equivalent. So basically this load statement on line 3 gives you a run binary. And then to make a Mocha test, you just needed to run the Mocha tool with some arguments. And to get it to report the right things, like you need to throw in like, some environment variables, like you got to use lots of attributes here to like interface them together, but you didn't need a custom rule for that either. Tool chains is a thing that you would typically do in a custom rule. There's nothing stopping you from just using HTTP archive, even if cross platforms, and then use a select to get the right one. And I've always been terrified that the right-hand side of select would cause an eager fetch, but apparently this is no longer the case. I feel like this used to be the case, but the fact that like, the user loads this build file, is it going to cause a fetch of all three of these Terraform binaries? I believe the answer is currently no.
It will under query until you run query. Yeah.
When they run query, it's going to get
Yeah,
default
because query has no transitions.
because it's not configured.
Yeah.
But when they run cquery, they won't. Okay, yes, makes sense. Users should always run cquery anyway. Like, would have been nice if that was the default, and the other one was like uquery. Sorry, it's not time to make names. Okay, good answer. So the other way to resolve this, no, this is hard to resolve. That's true. There's not a way out if they query and they fetch all of them, but a build should not have to fetch all of them. Okay.
It should be fine to fetch them. The idea is like you should have a very simple thing that declares the toolchain, and another repo that actually contains the big thing to download, so that even if you fetch this, it's fine.
Oh, I see. You're saying like this thing would then lazily go and download it later. Well, then you have like supply chain attack of like I gave Bazel all of the content addresses of the stuff I downloaded. Now like I get something dynamic later that doesn't. I don't get the guarantee anymore. The Bazel downloader cache basically doesn't save me from fetching it again later by accident, that kind of thing.
I don't really know what that means, but that's what Bazel itself does for like Java tools.
I think what Shkodon is referring to is just two repository rules. One that does the fetch, and the other one that writes the build file with the toolchain definition. So you have the indirection.
Yes, yes, thank you. It's like the trampoline that we use for Bisselmon. Yeah, okay. So basically, you stick this build file into another workspace rule.
Yeah. Is that what I meant? Maybe we'll get. Yeah.
Okay. This slide doesn't even make a ton of sense for this talk anyway, because it's kind of separate from writing the macro. Another quick point. So providers can get you in trouble. If you're willing to write little adapter shims, then you can easily go from one provider to another. So this maybe is going to be part of the code lab upstairs. So if you get proto info from somebody, like this part is an actual custom rule, but it's very short. Like all we needed to do is grab this thing and return it as the default, 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 Yes, you can. Yes, default info is to run files. So if you're just doing a run binary style macro, it's up to the consumer to plumb those outputs into the tool they're later going to run.
Yeah, I don't know any way to get this to work with macros. I have tried many times.
No, I don't. I mean, you would basically have to do a shim like this, which is to say, give me a shim that's called like run files. And I think we even have one of these. I think we had to write in some other place where we did TS protos, which is basically whatever default infos come in, output them under both default info and transitive run files.
That's fixed in Bazel 6.
Oh,
At least if my cherry pick gets in.
okay. So somebody should review Fabian's change.
You all have to bug Evo about this, but there is a new flag that makes it work with native rules that actually makes them behave like the Starlight guide says. So everything that's in files, if you declare the data, also goes in run files.
Oh,
It's an incompatible flag that's already in, and now the flip also needs to get in.
might finally unjam that horror.
Yes. Okay, did anybody write that down? I'm gonna write that down.
Yeah, I'm gonna have to look at that.
Yeah. Okay, I think Symlink. Okay, just gonna breeze through these. So for Symlink Forest, we ended up having to fix Jest to do this. You could hack the runtime. Rules.js, we actually hacked the file system APIs to try to make symlinks look like non-symlinks in order to prevent tools accidentally walking outside the sandbox, which they all do. Crazy example. This SWC, which is written in Rust and has different behavior based on whether it thinks it's being run interactive. So there has to be a TTY attached to standard in when you run the tool. Still works with run binary so long as you run it underneath SOCAT, which is some sort of crazy hacker Linux utility that lets you stick TTYs as inputs to programs. Still works. I don't want to have to rewrite this Rust program. Yeah. Okay, I breezed through the rest. Sorry, that was a lot. I really liked all of the actual like answers to things from this group. So like, please come give the talk next time.